Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Before we start our lesson, we will begin with reciting surah. The first one will be Surah Al-Fatihah, Surah Taha ayat 1 hingga 5, Surah Al-Insyirah, Surah Al-Kafirun, and then Surah Al-Ikhlas by 3 times. After that, followed by selawat ke atas Rasulullah sallallahu alaihi wasallam. Kita niatkan selawat kita ni untuk memenuhi perintah Allah Subhanahu Wa Taala. Kita niatkan selawat kita ni untuk memenuhi hak Rasulullah Sallallahu Alaihi Wasallam. Kita niatkan selawat kita ni untuk mendapat syafaat Rasulullah Sallallahu Alaihi Wasallam di akhirat kelak. Dan kita niatkan segala bacaan surah dan selawat kita ni untuk kedua orang tua, keluarga dan seluruh umat Muhammad Sallallahu Alaihi Wasallam. Kemudian doa sebelum belajar, semoga dengan usaha ini akan membantu pelajar agar mudah memahami dan dibukakan hati para pelajar untuk mencintai ilmu. Okay?
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم
الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. بسم الله الرحمن الرحيم طه ما أنزلنا عليك القرآن لتشقى إلا تذكرة لمن يخشى تنزيلا ممن خلق الأرض والسماوات العلى الرحمن على العرش استوى. بسم الله الرحمن الرحيم ألم نشرح لك صدرك ووضعنا عنك وزرك الذي أنقض ظهرك ورفعنا لك ذكرك فإن مع العسر يسرا إن مع العسر يسرا فإذا فرغت فانصب وإلى ربك فارغب. بسم الله الرحمن الرحيم قل يا أيها الكافرون لا أعبد ما تعبدون ولا أنتم عابدون ما أعبد ولا أنا عابد ما عبدتم ولا أنتم عابدون ما أعبد لكم دينكم ولي دين. بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد. بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد. بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد.
اللهم صل على محمد وعلى آل محمد 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 محمد اللهم صل على محمد وعلى آل 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 محمد
Doa sebelum belajar. Bismillahirrahmanirrahim. Allahumma aftah alaina hikmataka wanshur alaina min hazaini rahmatika ya arhamar rahimin. Ya Allah, bukakanlah ke atas kami hikmat-hikmat-Mu dan limpahilah ke atas kami khazanah rahmat-Mu, wahai yang maha pemurah lagi maha penyayang.
Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Ya Rabbku, lapangkanlah untukku dadaku dan mudahkanlah untukku urusanku, dan lepaskanlah kekakuan dari lidahku, supaya mereka mengerti perkataanku.
Amin.
Amin, 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 Ya Rabbal Alamin. In this session, we will discuss about topic 3.2, topic probability, and it will include 5 subtopics: introduction to probability, probability scale, mutually exclusive outcomes, theoretical probability, experimental probability, and finding probability in simple context. Can you please get ready with your notes, page 147 until 164, and your worksheet, page 136 until 143. And this will be our last topic for year 7. Okay, don't worry, this topic is not that difficult. Okay, it's not that difficult. You just need to focus with the terms, okay, the way how to solve it, and you should be survive. Okay, in this session, I will complete all the subtopics in our topic probability. So you need to highlight these key topics. Okay, first, introduction to probability. Second one, probability scale. The third one, mutually exclusive outcome. Fourth, theoretical probability and experimental probability. And last one, finding probability in simple context. Introduction of probability. Learning objectives. At the end of the lesson, students should be able to recognize real-life examples of probability. Second, explain the concept of probability and use the vocabulary of probability when describing events such as certain, more likely, equally likely, less likely, or impossible. Okay? And steps to success, please copy this on in your notes. First, explain the definitions of probability. Second, Give real life examples of probability. And last one, use vocabulary of probability when describing events. Now, what is actually probability? Probability is the chance or possibility that an event we call something events, as events in probability, okay, will happen. So probability is actually the possibility that something or that events will happen, okay. Probability can be expressed as fractions, decimal, or percents, but usually we express our answer by fraction, okay. And probability must always be a number between 0 and 1. Inclusive means includes of 0 and 1. Sample space in probability means the set of all possible outcomes or elements, okay? The set of elements. Events, as I mentioned earlier, event is something, okay? In probability, we call it events. And what is actually the definition of these events? Consists of one or more outcome. Okay, it relates to the sample space. Events relates to the sample space. It has the symbol E. We calculate its probability as a fraction, although we can express probability in decimal and percentage, but most of the time we express our probability or calculate probability as a fraction. So you must recall your fraction, your basic of fraction. Okay, and here will be the vocabulary that will be used in probability when describing events. We need sometime there will be question that ask you to describe the events, okay? And these are the vocabulary that you can use to explain or to describe the events. First, certain, impossible, possible, likely, unlikely, more likely, less likely, equally likely. Okay, here are the vocabulary of probability that you need to comprehend, and you need to know how to apply in describing the events. Okay, here will be the vocabulary of probability when describing events. The first one will be certain. Certain means will definitely happen. For example, the sun will rise and set every day. People will breathe air. Okay? Impossible will not happen. Growing wings, going to the sun, or breathing under water. Possible could happen, may or may not actually happen. For example, visiting another country or getting a new pet. Likely will probably happen. Read from a book next week. Unlikely will probably not happen, but not impossible. Okay, such as getting a pet tiger. Some people do have pet tiger, but it is uncommon. It is more likely that they will eat at break time than do their homework. Less likely, it is less likely that they will leave school early to go to Jurudong Park. Equally likely, it is equally likely for a coin to land on heads or tails. For this example one, you need to write a sentence by using these probability words. So you can do your own sentence. For part A, always, sometime, never. Part B, sorting possible and impossible sentences. You may write your own sentences on the chart below. For part C, likely and unlikely. For part D, certain and impossible. You can read the examples here and build up your own sentence. Example 2, I will give you 20 seconds to try. Okay, now there is a bag of blue gumballs. Okay, you want to share them with your friends, They cover their eyes and pick one randomly. Okay, for part A, what are the chances that a blue gumball will be picked? Certain or impossible? The answer is certain. Okay, because all of them are blue gumballs. Okay, for part B, what are the chances that a red gumball will be picked? The answer is impossible. Why? Because all of them are blue gumballs. Things like that. Okay, so just be careful with these kind of questions. Example 3, I will give you 20 seconds to try. Okay, which phrase from the box best describes the likelihood of each of these events? You may use each phrase more than one. Okay, so here you have impossible, unlikely, likely, certain, and equally likely. Now, for part A, rolling a 9 on an ordinary 6-sided dice. So, your answer is impossible because we only have until 6. For part B, rolling a number greater than 1 on an ordinary 6-sided dice. The answer is likely because we have 2, 3, 4, 5, 6. For part C, you take a green counter from a bag that only contains black counter. So what do you think? Okay, the answer is impossible. Of course, impossible. For part D, a die picked at random ending with the letter Y. The answer is certain. Why? Because you can pick Monday, you can pick Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. All of them ending with the letter Y. For part E, a newborn baby being a boy, so equally likely. Okay, equally likely. Why? Because it's either boy or girl. Next, probability scale. Learning objectives. At the end of the lesson, students should be able to explain the probability scales, use the probability scale. A certain outcome is 1 or 100%, an impossible outcome is 0 or 0%, and an equally likely outcome is 0.5, half, or 50%. Steps to success. Please copy this down in your notes. The first one, explain probability are given on a scale of 0 to 1. Explain a certain outcome is 1 or 100%, and an impossible outcome is 0 or 0%. And the last one, explain equally likely outcome is 0.5, half, or 50%. Probability scale. Here we need the number line. Okay. Probabilities are given on a scale of 0 to 1 as decimal or as fraction. Sometimes probabilities are expressed as percentage using a scale of 0% to 100%. Okay. This one is the probability scale. And actually this one, you need to recall your number line. It can be the fraction strip. Okay. It really relates to this probability scale. Fraction, number line. Okay. Use your previous knowledge to answer the questions in this probability scale. Now, here you can see that a certain outcome is 1 or 100%, and impossible outcome is 0 or 0%. If the events are certain, so it is of course 100%. Okay, and if the events are impossible, of course it is 0 or 0%. And when the events is equally likely outcome, it will be half. Okay, 0.5, 1 out of 2, or 50%. Okay. Other than that, you need to look at the questions. You need to know the fraction of the questions and be flexible with the questions. Okay. Such in this example for Lily rolls an ordinary six-sided dice. This will be the sample set for six-sided dice. Okay. We have 1, 2, 3, 4, 5, and 6. Now, marks with across the probability that Lily get an 8. It is clearly shown that Lily rolls an ordinary six-sided dice, so it is impossible for Lily get an 8. If it is impossible, so the probability that Lily will get an 8 will be 0. Okay? Now, for part B, mark with a cross that the probability that Lily get an even numbers. Now, P here means probability, bracket, even numbers. Probability of even numbers, as you can see here, we have 2, 4, and 6 even numbers, okay? 2, 4, and 6 are even numbers. So we have 3, right? Put it here 3, and at the bottom will be the total elements in the sample set. Okay, as you can see here, we have 6 elements, 6 values, 1, 2, 3, 4, 5, 6. So put it at your denominator. Once you simplify, you will get half, right? So it is exactly at the middle of this scale, like this. Okay. Example 5. I will give you 20 seconds to try. Okay. Nazmi has a bag holding red, white, and green counter. Altogether, there are 6 counters in the bag. The probability scale shows the probability that a counter picked at random will be red. It also shows the probability that a counter picked at random will be white. Show on the probability scale here, the probability that a counter picked at random will be green. Okay. Now, if you see here, the total counter is 6, and if you can see here on the probability scale, you have 0 and you have 1. So for probability, the minimum will be 0, the maximum will be 1. Just remember that one. Okay. Now, 1 here representing the maximums of this counter. Therefore, when we have 6 counter, and here the maximum value will be 6. Okay, and I will use fraction, okay, to demonstrate all of this probability on this scale. Okay, if the maximum is 6, therefore here also 6. Okay, and each of these scale will be out of 6, right? So we have 1 out of 6, 2 out of 6, 3, 6, 4, 6, 5, 6, and 6 out of 6. Now, you have red at 1, 6, and you have white at 3, 6. Therefore, you already have 4, 6, correct? So, the difference of this 6 out of 6 with 4 out of 6 will be the fraction for that green. Okay, so 6 out of 6 here minus 4, 6, and the answer will be 2 out of 6. Okay, and don't forget to draw an arrow on the probability scale which representing that green color. So like this. Okay, so now we already complete this example 5. Example 6. I give you 20 seconds to try. Okay, the diagram shows a probability scale with decimal values, so be careful. Write the letters for the probabilities of these events on the probability scale. The first one has been done for you. For letter A, the probability of a new baby being a boy. So the answer is 0.5. Why? Because it's either girl or boys. It is equally likely. Therefore, 0.5. We put A on that 0.5. B. The probability of picking a blue pen from a box containing 2 black pens and 8 blue pens. So the total pens here is 10 and the total for blue pens is 8. So when we express it in terms of decimal, it is 0.8. So B will be here. C. The probability of rolling a 7 on a dice with faces number 1 to 6. Of course, it is impossible. If it is impossible, that means on the scale it is 0. So put C here. The last one, D. The probability of picking the letter M at random from the letters in the word game. So in the word game, we have one letter M out of 4 letters, correct? So we express it in fraction, 1 out of 4, and the answer is 0.25. Remember, here we are talking about probability. So when we talk about probability, we need to express the answer, the total of the event that we want out of the total of the sample set, the elements. Okay, remember that one. We always express it in terms of fraction, but it also can be expressed through percentage or decimal like this. Okay, and the answer is 0.25. Therefore, D is here. Example 7. Martin has a present to wrap. He has a choice of 3 colors of wrapping paper: blue, red, or green. He had a choice of 2 colors of ribbon: yellow or green. Martin chooses the wrapping paper and the ribbon at random. Complete the table to show all the possible color combination. You may not need all the rows in the table. So part A, you need to combine all the possible color combination. Okay, so red can be with yellow, red can be with green, green can be with yellow, green can be with green. Okay, so for part B, write down the probability that the ribbon is the same color as the wrapping paper. Okay, I give you 20 seconds to try. So the answer is 1/6. Okay, this one. Only one outcome. Okay. Example 8. I give you 1 minute to try. Okay, now a fruit bowl contains apples, bananas, and oranges. The number of each type of fruit is shown in the table. So we have apple, we have banana, and we have orange. Okay, Awin takes a piece of fruit from the bowl at random. So your task is you need to draw an arrow to place each of the following events on the probability scale. So we have four events here. The first one has been done for you. Okay, on this probability scale, always for probability, the minimum will be 0 and the maximum will be 1. Again, for a probability, the minimum will be 0 and the maximum will be 1. Okay, now the second one that you need to look at, the total number of fruits is 12. So the maximum of this probability will be 12 out of 12. Okay, and when we fill all of this scale, we have 10 out of 12, 8, 12, 6, 12, 4, 12, and 2, 12. Okay, now we start with this one. Probability of event E is already given, so it is 6 out of 12. This one, E is banana, so banana is 6, 6 out of 12, and it is half actually. Okay, so 6 out of 12. Don't forget to draw the arrow and put the letter. Okay, second one, even F. Even F is takes out an orange. Orange we have 4, so for 12. The next one, even G, probability of even G does not take out an apple. Does not take out an apple. So G, when Awin take out apple for 2, therefore even G will be 10 out of 12, and the answer is here. And the last one, probability of even H. Awin takes out a strawberry. We don't have strawberry here, so 0. Therefore, even H will be at 0. So please complete your notes and copy down all of these workings. This one and this fraction, please copy it down. Next, mutually exclusive outcome. Learning objectives. At the end of the lesson, students should be able to identify all the possible mutually exclusive outcomes of a single event. The second one, explain that mutually exclusive are events that cannot happen at the same time, and the sum of the probabilities is equal to 1. Steps to success. Number 1, explain all the possible mutually exclusive outcomes of a single event. Second, show that mutually exclusive events cannot occur at the same time. And the last one, explain that the sum of probabilities of all mutually exclusive outcome of an event is equal to 1. Mutually exclusive means events that cannot happen at the same time. Okay, cannot happen at the same time. It is impossible for them to happen together. Okay, it is impossible for them to happen together. The probability of both events happening together is 0. Okay, so the keywords for this mutually exclusive events cannot happen at the same time. It is impossible for them to happen together. Okay, remember that one. For examples, turning right and left. Of course, if we want to turn right, we will turn to right and then we turn to do the left. It is impossible for us to turning right at the same time with left, right? The second one, tossing a coin, heads and tails at the same time. No, it should be heads or tails, right? Then, for example 3, today is Monday and today is also Tuesday. Of course, it is impossible. Okay, if it is Monday, it will be Monday, and tomorrow will be Tuesday, like that. Okay, so this mutually exclusive outcome that is impossible to be the same. Okay, events that cannot happen at the same time. Impossible to happen together. Example 9. Could the two events A and B in the following situations happen at the same time? Okay, so put your answer yes or no. Now, for part A, even A, roll a dice and get a 1. Even B, roll a dice and get a 6. The answer is no. For part B, even A, toss a coin and get heads. Even B, toss a coin and get tails. The answer is no. Why? Because they cannot happen at the same time. Now, I will uh, give you 20 seconds for you to try for part C, part D, and part E. 20 seconds from now. Okay. Part C, a bag contains 2 yellow balls and 3 blue balls. A ball is drawn from it. Even A, you get a yellow ball. Even B, you get a blue ball. And the answer is no, because they cannot happen at the same time. For part D, even A, roll a dice and get a 2. Roll a dice and get an even number. The answer is yes, because 2 is even number. For part E, one student is selected as the class monitor. Even A, Jamal is selected as the monitor. Even B, Peter is selected as a monitor. The answer is no, they cannot be happen at the same time. We need to choose only one class monitor. So the answer is no. So, if A and B are mutually exclusive events, then probability of A or probability of B. We need to select one of them. If you want to choose both, it must be impossible. Okay, so how to write the probability for mutually exclusive events? We put like this: probability of A or probability of B. And how are we going to solve the probability for mutually exclusive events? We add. Okay, probability of A, add plus probability of B, like that. Remember, if here is OR, it shows that it is mutually exclusive events. And how to solve it? We need to add both of the probability. It is because two mutually exclusive cannot occur at the same time. They have no outcome in common. The probability that either events may happen is the sum of the probabilities of the events A and B, as mentioned earlier in this part. Okay, so this will be the calculation to find the probability for mutually exclusive events. Okay, and for this one, this is the basic for your probability of an event, and probability actually can be expressed through decimals or percentage, but most of them we solve it through fraction. Okay, and this one actually what we already cover in our probability scale in our previous slides. Okay, now the sum of the probabilities of all mutually exclusive outcome of an event is equal to 1. Okay, remember this one. The sum of the probabilities of all mutually exclusive outcome. Mutually exclusive outcome, the event should be equal to 1. Okay, I repeat myself. The sum of the probabilities of all mutually exclusive outcome must be 1. Next, example 10. Form 3C is looking for a new monitor. The probability of John becoming the monitor is 0.2 and the probability of Jenny becoming the monitor is 0.4. What is the probability of either John or Jenny becoming the monitor? As you can see here, we have this key or If we have OR here, that means this probability is mutually exclusive outcome. And how to solve this mutually exclusive outcome? We do like this. Okay. P means probability of John or Jenny. And remember, if here is OR and we need to add. This one is your probability of John and this is the probability of Jenny. We just add them and the answer is 0.6. That will be your final answer. Okay, so the answer is 0.6. Next, example 11. Roll a dice. Even A roll a dice and get a 1. Even B roll a dice and get a 4. Now, the sample set for a dice will be 1, 2, 3, 4, 5, and 6. Okay. And then, now let us answer part A. The probability that you get a 1. This one. Okay. So we have one outcome out of 6 here. Possible answer. Therefore, the answer is 1 out of 6. Okay. The probability that you get a 4. So, here, this means probability. Okay. Probability of A. And this one is probability of B. The probability of B get a 4. So this is 4. So we only have one possible outcome out of 6 possible answer here. Possible outcome here. Alright. Therefore, the answer is 1 out of 6. Now, for part C, the probability of getting a 1 or a 4. Remember, here we have OR. Okay, if OR, that means this event is mutually exclusive outcome. And when it is mutually exclusive outcome, you need to add both of this probability like this. Okay, probability of A plus probability of B, and you will get 2 out of 6. If you simplify, you will get 1/3. Okay, that is how you answer this kind of questions. Example 12. I give you 20 seconds to try. Okay, now spin to win a prize. So you spin the wheel which has 4 equal sectors. For even A, you get a calendar. Even B, you get a cash coupon. For probability of A will be 1 out of 4. Okay, P is probability, and put bracket and put what you want on that inside the bracket. So here you get a calendar, and you don't have to write down you get a calendar in this bracket. You just put A, which representing you get a calendar. Okay, now probability of B, you get a cash coupon, so the answer is 1/4. The probability of getting a calendar OR. Okay, now we can see the word OR. So if we see the word OR, so this is mutually exclusive even. Okay, therefore the answer is half. Okay, and here is the working. Here is the working. P probability of A or B equal to 1/4 plus 1/4 will give you 2/4, and when you simplify you will get half. Okay, example 13. I give you 20 seconds to try. Okay, example 13. A bag contains 2 yellow balls, 3 green balls, 5 red balls, and 6 black balls. What is the probability of either a yellow ball or a red ball being drawn if only one ball is drawn. So here you need to find out the probability first, because probability is not given. What given here is only values. So probability of yellow will be 2 out of 16. Why 16? 2 plus 3 plus 5 plus 6. Okay. And then you need to find out the probability of red. Red is 5 out of 16. Therefore, you add both of this fraction and the answer is 7, 16. Yes, 7 out of 16. Example 14. 20 seconds from now. Okay, now draw a colored ball from the back. Draw here bukan lukis. Draw here means you take out. Okay, you need to take out a color ball from the back. There are 5 balls of different colors: orange, yellow, red, blue, and white inside a bag. For even A, draw a white ball. Even B, draw an orange ball. So for probability of A, the answer is 1 out of 5. Okay. For B, the answer is 1 out of 5. The probability of getting a white or. Okay, we have or here. That means this is mutually exclusive, even. Therefore, you plus both of this fraction and you will get 2/5. Okay, remember, if or, you must plus. Now, discussion. In the above cases, even A and B are, as I mentioned earlier, it is mutually exclusive events. Okay, state the relationship between P bracket A, P bracket B, and P bracket A or B. Then P bracket A or B should be the additions of PA, probability of A, plus probability of B. Why? Two events cannot occur at the same time, so that they have no outcome in common. Therefore, the probability that either event may happen is the sum of probabilities of the event A and B. Okay? Don't forget to copy this down in your notes, exactly as what I share with you in these slides. Okay? No shortcut, no shortcut. And especially for this explanation, some of the exam question will ask you to explain. So just recall the definition and the concept of that topic, and use that concept and definition to answer this kind of questions. Okay. Next, theoretical probability and experimental probability. Learning objectives. At the end of the lesson, students should be able to define and differentiate theoretical probability and experimental probability. Second, estimate probabilities based on data collected from simple experiments. And the steps to success. First, define theoretical probability and experimental probability. Differentiate theoretical probability and experimental probability. And last one, estimate probabilities based on data collected from simple experiment. Theoretical probability. The theoretical probability of an event is the number of ways the event can occur, bracket favorable outcomes, divided by the number of total outcomes. Okay, so the theoretical probability is what you expect to happen, but it is not always what actually happened. You don't have to think too much about this one. This theoretical probability is actually just what we already done in our previous subtopic, in our mutually exclusive outcome, in our probability scales, in finding the probability of the events. That is actually theoretical probability. Okay. That is how you will solve theoretical probability, like your previous subtopic. This will be the formula to find theoretical probability, and you don't have to worry for remembering this formula, because this formula is actually same like the formula that we used to find out probability in previous subtopics. Okay, how we find out the probability of even A, how we find out the probability of previously we try to find out probability of banana. Okay, so same like our previous discussion. Okay, so our previous discussion is actually theoretical probability. Just remember that one. Now, example 15. A bag contains 10 red marbles, 8 blue marbles, and 2 yellow marbles. Find the theoretical probability of getting a blue marble. You circle the word theoretical probability because later on we're going to discuss about experimental probability. Okay, and remember, theoretical probability is same like how we find out the probability in previous subtopics. All right, now we're going to get a blue marble. Blue marble, we have 8 here. Okay, we have 8 blue marble here. So the number of favorable outcome will be 8, and the total outcome, you add them all, 10 plus 8 plus 2, and it should be 20. And then P events, number of favorable outcome, number of total outcome. Here you can add P bracket blue. Okay, P bracket blue equal to 8 out of 20, and you simplify, you will get 2 out of 5. Same like how we find the probability for previous questions. Okay. Example 16. A spinner is divided into 8 equal sectors, number 1 through 8. For part A, what is the probability of spinning an odd number? So here you need to look for probability of odd number, and from this spinner we have 4 odd number, which are 1, 3, 5, and 7. So the probability is 4 out of 8, and the answer is half. Okay, now I will give you 20 seconds to try that B and C. Okay, now divisible by 4, so we have 4 and 8, and the probability of divisible by 4 is 2, 8, and when we simplify it will become 1/4. Okay, for part C, less than 3, so probability of less than 3 it is 2, so 2 out of 8, and when we simplify it become 1/4. Experimental probability. Now, experimental probability refers to the probability of an event occurring when an experiment was conducted. How to find the experimental probability? First, you conduct an experiment and record the number of times the event occurs and the number of times the activity is performed. Usually in exam questions, you are given the outcome of the experiment. Okay. Step 2, divide the two numbers to obtain the experimental probability. The formula for experimental probability of an event is number of time event occurs, and always the denominator will be the total. Now, this example 17, it mentioned that 13 out of 20 emails in your inbox are junk emails. What is the experimental probability that your next email is junk? Okay, so circle experimental probability because sometimes the question asks you about theoretical probability. So circle experimental probability. And you just look for the key information from this question. So 13 is the number of times event occurs. Okay, and total number of trials 20. We cannot simplify further, so 13 out of 20 is the final answer. Example 18, I will give you 20 seconds to try. Okay, a bag contains 10 red marbles, 8 blue marbles, and 2 yellow marbles. Find the experimental probability of getting a blue marble. And the solution, step 1, take a marble from the bag. Step 2, record the color and return the marble, repeat for 10 times. And here is the result. Therefore, the experimental probability of getting a blue marble from the bag is 6 out of 10, and simplified will give you 3. Moving on with example 19. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days will you expect in April? Now, step 1, you need to find out the experimental probability first of a rainy day. And this one should be here. Okay. So, for step 1, we focus with the information in March. So, the number of time events occur is 2, and 12 will be the denominator, like this. And then you simplify, you will get 1 out of 6. Now, step 2, to make a prediction, you need to multiply the probability of a rainy day by the number of days in April. You already have the probability of rainy day by using the informations in March, which is you got 1/6. Therefore, to predict, you need this probability and you multiply the number of days in April. In April, we have 30 days. Therefore, 1/6 times with 30, and the answer is 5. There will be 5 rainy days in April. Okay, you just follow what the information given and it should be okay. Okay. Next, comparing experimental and theoretical probabilities. Here we can compare the answers that we get from experimental probabilities and the answer that we get from the theoretical probabilities. Okay. In your notes, it is clearly explained about experimental probability and theoretical probability. Okay. Experimental probability is found by repeating an experiment and observing the outcome. And usually in exam, you are given the result of the outcome. You just need to directly use the formula to find out the experimental probability. Okay. And this theoretical probability is what is expected to happen based on mathematics. And here will be the formula. I already discussed the formula in our previous slide. Okay. Now, in this example 20, a coin is flipped 20 times and it lands on head 13 times. Which is higher, the experimental or theoretical probability of flipping heads? Now, this information is useful for experimental probability. For your theoretical probability, you just need to remember a coin, you have 2 favorable outcomes, head or tails. That's it. Okay. So, step 1 here, it mentioned about find the experimental probability. So, you use this information, 13 out of 20, 20 always the total. So 13 out of 20, you will get 65%. This answer is for experimental probability. While in step 2, here we're going to find the theoretical probability of the events. Remember, theoretical probability for a coin, we only need 2 favorable outcomes. We only have 2 favorable outcome, which is head or tails. Therefore, it's half here, which is 50%. Okay. And step 3, compare the experimental and theoretical probabilities based on the problem. Answer: the experimental probability is 65% and the theoretical probability is 50%. So the experimental probability of flipping heads is higher than the theoretical probability. You don't have to worry with this kind of questions in exam. If this question come out in exam, just focus with the basic of theoretical probability and basic of experimental probability. And if you need to explain the comparison, you just use your answers to do the comparison in your explanation. Alright? The next one, example 21. A fair six-sided number cube is rolled 40 times. A 4 is rolled 6 times. Which is higher, the experimental or theoretical probability of rolling a 4? Now, if you are given this kind of information, this is for experimental probability. Okay, and for your theoretical probability, you just remember six-sided number cube. A cube, we only have 6 sides, so the favorable outcomes, the total for favorable outcomes is 6. Okay, and rolling a 4, it always be 1 out of 6. Just remember that one. And repeat the same step as previous example. Find the experimental. So 6 out of 40, like this. And since here we have percentage, we need to convert this fraction into percentage. 6 out of 40 times with 100, you will get 15%. While for theoretical probability, the probability of rolling a 4 will be 1 out of 6. And when we change it into percentage, it is 17%. And for step 3, you need to compare the experimental and theoretical probabilities based on the problem. The experimental probability is 15% and the theoretical probability is 17%. So the theoretical probability of rolling a 4 is higher than the experimental probability. Next, example 22. The bar graph shows the result of rolling a number cube 50 times. What is the experimental probability of rolling an odd number? How does this compare with the theoretical probability of rolling an odd number? Now, odd number we have 1, 3, and 5, correct? 1 we have 10, 3 we have 8, this one, and 5 we have 8. So an odd number was rolled. You add them all, 10 plus 8 plus 8, you will get 26. Okay. So an odd number was rolled 26 times in a total of 50 rolls. In previous steps, we already have the number of times even occurs, number of times the odd was rolled, which is 26 out of 50. You simplify, you will get 13 out of 25. And then since here we have percentage sign, so we convert your fraction into percentage, will give you 52%. We already have the probability, the experimental probability for rolling and odd numbers, which is 52%. And now let us find out the theoretical probability of the events. Now, for odd number, we have three favorable outcome, right? 1, 3, and 5. And total possible outcome is 6. 1, 2, 3, 4, 5, and 6. So, for theoretical probability, odd number 3 out of 6. You simplify, become half, you change into percentage, you will get 50%. And the last step, you compare the experimental and theoretical probabilities based on the problem. The experimental probability is 52% and the theoretical probability is 50%. Therefore, the experimental and theoretical probabilities are similar. Even the experimental probability is a bit higher than your theoretical probabilities. Next, the last subtopic, finding probability in simple context. Example 23, I will give you 20 seconds to try. Okay, example 23, in a class of 40 students, 8 are in the Al-Quran club and 12 are in the Bahasa Arab club. If a student is selected at random, what is the probability that the selected student is in the Al-Quran club? So, probability of Al-Quran club equal to 8 out of 40 and the answer is 1/5. For part B in the Bahasa Arab club, so probability of Bahasa Arab club equal to 12 out of 40 and the answer is 3 out of 10. Example 24, I give you 1 minute to try. Okay. Example 24. There are 20 counters in a bag. 2 of the counters are white, 1 of the counters is pink, 4 of the counters are black, the rest of the counters are purple. Carter takes a counter at random from the bag. Show that the probability that the counter is white or purple. We have or here, so it is a mutually exclusive outcome. Therefore, for purple it will be 13. Yes, so when they said show, so you need to display all of the workings. You need to do all of the workings, and here you have probability of white or purple equal to probability of white plus probability of purple. So 2 out of 20 plus 13 out of 20, and the answer is 15 out of 20. Simplify, become 3/4. Or example 25, you ask a friend to think of a number from 2 to 12. What is the probability that his number will be 4? Before that, don't forget to do these 3 dots, okay, therefore shown. And back to example 25. So from 2 to 12, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Probability that his number will be 4. And as you can see here, we have 1 4 here. So 1 out of 11. And the final answer is 1 out of 11. Now, example 26 and 27. I give you 1 minute to try. Okay. Example 26. A bag contains 6 purple sticks, 2 orange sticks, and 4 black sticks, and you ask a friend to pick one without looking. What is the probability that the stick will be purple? And the total values will be 12, so purple. Probability of purple will be 6 out of 12, and simplify, you will become half. Example 27. The probability that you randomly draw a short straw from a group of 40 straw is 320. How many are short straw? So here the probability is given, and here you need to find out the number of short straws. Okay, so total short straws equal to 3 out of 20 times 40, and the answer is 6. Next, example 28. I give you 1 minute to try. Okay, Firdaus has some sweets in a bag. 5 of the sweets are lemon flavor. 7 of the sweets are strawberry flavored. The rest of the sweets are mint flavored. The probability that Firdaus takes a mint flavor sweet is 2/5. How many mint flavor sweets are in the bag? So here you need to find out the total of mint. And here, when you add 5 plus 7, and the answer is 12. So the question asks you about mint flavor. So mint flavor is 2/5. Therefore, the 3/5 will be lemon and strawberry. Correct? So 12 is for this 3 column, and we need to find out one box, and one box is 4, and all boxes will be 4. Therefore, the answer is 8. Example 29. I give you 1 minute to try. Okay, now the table shows the shoe size of 23 students. And for part A, you need to work out the probability that the student has a shoe size of 8. Okay, a student is picked at random, and here is the frequency table. And for part A, you need to look for probability of student has a shoe size of 8. So here, probability of student who has a shoe size of 8 equal to 4 out of 23. Therefore, the final answer is 4 out of 23. For part B, work out the probability that the student has a shoe size of 7 or smaller. Okay, so 7 or smaller. So, probability of shoe size of 7 or smaller, probability of student who has shoe size of 7 is 5 out of 23, and probability of student who has shoe size smaller, this one we combine this 11 and 2, which is 13. Okay, so 13 13 out of 23, and we add them all, so the total will be 18 out of 23. Remember, for probability, the answer always in fraction. Okay, unless the question asks you to give your answer in decimal or percentage. Okay, must be in percentage. If you just write down 18, and it will be incorrect. All right. Example 30. I will give you 1 minute to try. Okay. A box contains Lego blocks of the same size. Each block is white, blue, green, or red. Okay. So here is already the probability. Okay. Here is already probability. The table shows the probabilities that a block picked at random is white, blue, or red. Work out the probability of a green blocks. So we just simply subtract all of here, all of this probability from 1, like this. Okay, why? Because the maximum for probability is 1. So 1 minus 0.25 minus 0.45 minus 0.2, and the answer is 0.1. And the probability for green is 0.1. And for the part B, there are 60 red Lego blocks. So, how many white Lego blocks are there? Now, here you can use the equivalent method. Since you have complete information for red Lego blocks, and again, here this is the probability, it is not values. Okay, and for this part B, you need to find out the value for white Lego blocks. Okay, so you are given that the probability for red is 0.2 and the total is 60. What will be the total for white when the probability for white is 0.25? Okay, now look here. How are you going to get this 0.25? You multiply 0.2 with 1.25, both sides. Okay, if you multiply here 1.25, and here also you need to multiply 1.25. Therefore, the total for white Lego blocks will be 60 times 1.25, and the answer is 75. Therefore, the answer for part B is 75. Example 31. I give you 1 minute to try. Okay. Alex organizes a raffle for his school fire. The top prize is a ride in a hot air balloon, which will be won by one ticket. Altogether, Alex sells 700 raffle tickets. Miss Robinson buys 5 tickets for the raffle. Work out the probability that Miss Robinson does not win. Okay, here Miss Robinson only buy 5 tickets, so her chances to win the prize will be only with these 5 tickets, correct? And be careful here, the question asks you to figure out, to work out the probability that Miss Robinson does not win. Therefore, probability bracket does not win equal to 700 minus 5 divided by 700, and then 695 divided by 700, and when you simplify you will get 139 out of 140. Okay, example 32. I will give you 1 minute to try. Okay, at a clothing company, an inspector finds 5 defective pairs of jeans in a shipment of 200. If this trend continues, about how many pairs of jeans will be expected to be defective in a shipment of 5,000? Here I will show you 2 methods. Method 1 is cross multiplication method. If 5 defective, if the total is 200, it will be 5 defective pairs of jeans. Okay, so expect to be defective when 5,000 shipments of pair of jeans. Okay, so we're going to find this one, expect to be defective, and when we express it like this, so 5 out of 200 equal to, I put x for the unknown value here, x divided by 5,000, so cross multiplication, 200x equal to 5 times 5,000, and 200x equal to 25,000. We remove that 200 to get that x, so x equal to 25,000 divided by 200, and the answer is 125 pairs with defects. Okay, This is the method 1. Please copy both of this method in your notes. For the second method is by equivalent method. When the total is 200, the defective is 5. So what will be the total for defective if the total is 5,000? 5,000. So how to get this 5,000? 200 times with 25. When we multiply here 25, so the other side also multiply by 25. Alright? So how to find the value of x? 5 times this 25, and still you will get 125. Therefore, the final answer for example 32 is 125. Please complete your notes and complete your worksheet. Okay, and this will be our last session, our last topic for year 7. So please make sure you complete all your notes, all your worksheet, and as usual we will end our session by reciting dua. Thank you so much, and Assalamualaikum warahmatullahi wabarakatuh.
Doa selepas belajar. Bismillahirrahmanirrahim. Allahumma inni astaudi'uka ma 'allamtani fardudhu ilayya inda hajati ilaihi wala tansani ya Rabbal Alamin. Ya Allah, sesungguhnya aku menitipkan padamu ilmu-ilmu yang telah engkau ajarkan kepadaku, dan kembalikanlah kepadaku sewaktu aku memerlukannya kembali. Dan janganlah engkau lupakan aku kepada ilmu itu, wahai Tuhan yang memiliki semesta alam. Amin.